ठीक है। चलो भाई, चल अभी मत करो स्टार्ट। तो ये ना बस ठीक है, मैं कर दूंगा अपना बुक करना होगा, नए टॉपिक तो करूँगा। यस्टरडे हमने जो है क्या किया था, वॉल्यूम बाय दिस वॉल्यूम ऑफ द सॉलिड ऑफ रिवॉल्यूशन, वॉल्यूम ऑफ सॉलिड ऑफ रिवॉल्यूशन, यानी कोई भी सॉलिड चीज है उसको रिवॉल्व करें तो वॉल्यूम क्या निकल के आता है, दैट इज वॉल्यूम ऑफ द सॉलिड ऑफ रिवॉल्यूशन। वो आपके पास में उसके लिए हमने फॉर्मूला बनाया था और एग्जाम्पल भी लिया था, नहीं फॉर्मूला ही बनाया था सिर्फ। वी डेवलप द फॉर्मूला फॉर फाइंडिंग द वॉल्यूम ऑफ द रिवॉल्यूशन, यानी पोलर फॉर्म में भी बना लिया था। ये जर्नल आपके पास में अबाउट वाई एक्सिस अबाउट एक्स एक्सिस दो फार्मूले बनाए थे। व्हेन रिवॉल्व अबाउट द एक्स एक्सिस दिस विल बी द फार्मूला, व्हेन रिवॉल्व अबाउट द वाई एक्सिस दिस नंबर 2 विल बी द फार्मूला, एंड इफ इट इज इन द polar coordinate then it will become this one. Now let us consider the example. एग्जाम्पल लेते हैं हम इसके लिए। एग्जाम्पल है फाइंड by using the double integral, find the volume of the solid generated by revolving the ellipse x square divided by a square plus y square divided by b square is equal to b1 about the y axis, about the y axis। ये हमने करना है about the y axis। now solution, let us see the solution। अब हमारे पास में क्या है, ये इलिप्स है जिसको हमने रिवॉल्व करना है, दिस इलिप्स इज टू बी रिवॉल्व। तो हम उसी तरह से जैसे उसमें जर्नल जो पूरा रीजन हमारे आर था, उस रीजन में हमने एक यूनिट एरिया यानी एरिया ऑफ डेल्टा एक्स डेल्टा वाई का एरिया का सॉलिड को रिवॉल्व किया था और उसको फिर इंटीग्रेट करके जनरलाइज कर दिया था। बिल्कुल सेम वे में हमने यहाँ पर करना है। लेट अस कंसीडर द इलिप्स, सिंस द इलिप्स is symmetric, since the ellipse x square upon a square plus y square upon b square is equal to b1 is symmetric about the y axis, is symmetric about the y axis. So the volume generated by left and right half overlaps. So the volume generated by the left and the right half ओवरलैप कर जाएगा। so we consider the revolution of the right half। ठीक है, बना लेता हूं मैं फिगर। ये फिगर ऐसे बनेगा, मेजर एक्सिस ऑन दी एक्स एक्सिस बनेगी, अब उसी तरह से हमने यहाँ राइट को लिया है, तो ये डेल्टा एक्स डेल्टा वाई वाला ले लिया मैंने एक। ठीक है, इसमें हमारे पास में ये बन गया ए डैश बी बी डैश बी बी डैश। तो हमारे पास में क्या बन गया, राइट हाफ क्या बना, ए बी एंड बी डैश, ये बना। ओनली फॉर विच x varies from 0 to x की वैल्यू निकाली इस इलिप्स से, x की वैल्यू निकल गई आपके पास में 1 माइनस वाई स्केयर बाई बी स्केयर, और फिर ए स्केयर उधर चला गया, बी स्केयर से ले लिया, तो ये आपका आ गया ए बाई बी अंडर द रूट ऑफ एलसीएम लिया बी स्केयर माइनस वाई स्केयर, ये बन गया आपके पास। एंड y वेरीज फ्रॉम माइनस बी टू बी, माइनस बी टू बी, वाई तो पूरा हमने लिया है, वाई का यानी पूरा लिया है, माइनस बी टू बी, और एक्स का सिर्फ ये चीज ली हमने, यानी 0 टू दिस पॉइंट, इसको पूरा रिवॉल्व करना है एक तरह से। नाउ रिक्वायर्ड वॉल्यूम विल बी, therefore required volume is equal to be 2 pi, फॉर्मूला था माइनस बी बाई बी इंटीग्रेशन 0 टू a by b under the root of b square minus y square x dx dy, x dx dy। तो integrate it, 2 pi minus b to b integrate x का integration x square divided by 2 limit 0 to a by b under the root of b square minus y square dy। 2 से आपका 2 कैंसिल हो गया, अपर लिमिट माइनस लोअर लिमिट पुट की, तो दैट ओनली विल बी पाई इंटीग्रेशन माइनस बी टू बी, एंड अपर लिमिट पुट की हमने x की जगह पे, तो बन गया ए स्केयर अपॉन बी स्केयर इंटू बी स्केयर माइनस वाई स्केयर डी वाई, दैट इज इक्वल टू बी। अब अगर आप ध्यान से देखें माइनस ए टू ए, ये इवन ऑड फंक्शन वाला केस बन जाएगा, दैट इज इक्वल टू बी, इवन ऑड बन गया तो आपके अंदर क्या है, इवन फंक्शन है, तो ट्वाइस 2 पाई ए स्केयर डिवाइडेड बाय बी स्केयर, 2 पाई ए स्केयर डिवाइडेड बाय बी स्केयर 0 टू बी स्केयर माइनस वाई स्केयर ओनली, b square minus y square only dy, then it is equal to be 2 pi a square divided by b square इंटीग्रेशन किया b square y minus y cube divided by 3 0 to b, अपर लिमिट माइनस लोअर लिमिट, तो ये बन गया फर्स्ट b square इंटू बी क्यूब, नेक्स्ट b क्यूब डिवाइडेड बाई 3 एलसीएम 3 माइनस 1 2/3, यानी 2/3 वो बाहर आ गया, तो 4/3, और बी स्केयर ऊपर बी क्यूब है, बी क्यूब का बी स्केयर कैंसिल हो गया, दैट इज पाई ए स्केयर बी। आई थिंक यही आंसर आ गया, यही आंसर आ गया ना,
यस सर।
क्यूबिक यूनिट। इस तरह से सीधा फॉर्मूला लगाया, सिर्फ हमने देखा कि ये जो है, क्योंकि अगर पूरे को घुमाएंगे तो हमारा ओवरलैप कर रहा था, तो ओवरलैप करने की वजह हमने सिर्फ राइट वाला जो है राइट हाफ, इस राइट हाफ को रोटेट किया, इस राइट हाफ को रोटेट किया, उससे जो वॉल्यूम बना रिवॉल्यूशन अबाउट द वाई एक्सिस जो फार्मूला था, तो उसी से मैंने लिमिट निकाल दी, तो उससे लिमिट निकाल के यू विल गेट द आंसर। ठीक है, नेक्स्ट हम एक एग्जांपल ले लेते हैं पोलर फॉर्म का। एग्जांपल, evaluate the volume generated। अब जैसे ये बन रहा था वॉल्यूम ऑफ द रिवॉल्यूशन, ठीक ठीक ठीक, volume generated by the revolution of the cardioid R is equal to A into 1 minus cos theta about its axis, about its axis। यानी ये इस कार्डाइड में आपने ध्यान दिया हो कौन सी एक्सिस बनती, आर इज इक्वल टू ए पहले भी लिया, सेम कार्डाइड हमारे पास में पहले भी लिया है, ध्यान हो तो ये था कार्डाइड आपका, दिस विल बी द कार्डाइड। ये कार्डाइड था, ये इसकी एक्सिस कौन सी है, ये जो आपके पास में जीरो थीटा इज इक्वल टू बी 0 डिग्री वाली इसकी एक्सिस है, थीटा इज इक्वल टू बी 0 डिग्री आपके पास में इसकी एक्स एक्सिस जो इसकी एक्स एक्सिस है। यानी यहाँ पे थीटा हम बनाए, सपोज कोई भी हम रेडियस लें, ये आर है, दिस इज आर, और ये थीटा है, दिस इज थीटा। यहाँ पे थीटा की वैल्यू 0 है, यहाँ पे थीटा की वैल्यू पाई है। यहाँ पे क्या देखा, इवेलुएट द वॉल्यूम जनरेटेड बाय द रिवॉल्यूशन ऑफ द कार्डाइड अबाउट इट्स एक्सिस, अबाउट इट्स एक्सिस। तो पूरे को उसी तरह से पूरे को रिवॉल्यूट करेंगे तो हमारा ओवरलैप होगा, बिल्कुल सेम वे से जैसे ऊपर वाला किया था वो ओवरलैप होगा, तो हम अपर वाला हाफ ले लेंगे, वी कंसीडर ओनली द अपर हाफ, ये अपर हाफ ले लेंगे, ये वाला वी कंसीडर दिस पोर्शन, इस पोर्शन को हम रिवॉल्यूट करेंगे। ये हमारा थीटा था, since the उसी तरह since the upper and the lower halves of the cardioid generate the same volume, so we consider the revolution of the upper half only, for which r varies from क्या है 0 to a cos theta, r varies from 0 to a into 1 minus cos theta, and theta varies from 0 to pi, r varies from 0 to a cos a into 1 minus cos theta, and theta varies from 0 to pi, therefore required volume will become is equal to be 2 pi iota integration 0 to pi integration 0 to a into 1 minus cos theta r square sin theta dr d theta, that is equal to be 2 pi iota 0 to pi with respect to r इंटीग्रेट किया, sin थीटा बाहर कांस्टेंट है, r क्यूब divided by 3, 0 to a into 1 minus cos theta d theta. That is a cube 1 minus cos theta, that is 2 pi by 3 आ गया. इंटीग्रेशन a क्यूब बन गया इंटू 1 माइनस कॉस थीटा का होल क्यूब बन गया. तो a क्यूब भी बाहर ले लो. चलो 0 टू पाई साइन थीटा a क्यूब इंटू 1 माइनस कॉस थीटा का होल क्यूब d थीटा. 2 पाई a भी बाहर आ गया. 2 a क्यूब पाई डिवाइडेड बाई 3, 0 टू पाई, ये बन गया 1 माइनस कॉस थीटा का होल क्यूब इंटू साइन थीटा डी थीटा. तो क्या क्या आ जाएगा? कंसीडर 1 माइनस कॉस थीटा इज इक्वल टू बी टी. दिस इंप्लाइज कॉस थीटा का डिफरेंशिएशन माइनस साइन थीटा. तो ये हो गया साइन थीटा डी थीटा इज इक्वल टू बी डी टी. लिमिट पुट करें हम तो फॉर ओनली फॉर इंटीग्रेशन कर लें, वापिस कर लेंगे फिर. ओनली फॉर इंटीग्रेशन, only for integration, that is equal to 2a cube pi divided by 3. it means ये बन जाएगा t cube. t cube वो तो सारा dt में चला गया. तो ये इंटीग्रेशन आया 0 टू पाई t क्यूब यानी 1 माइनस कॉस थीटा t क्यूब का इंटीग्रेशन t की पावर 4 डिवाइडेड बाई 4. ये आपका आ गया. जीरो टू पाई 0 टू पाई. टू ए क्यूब पाई डिवाइडेड बाई 3 4 जा 12. वो कैंसिल हो गया. 2 6 आ गया. अपर लिमिट कॉस पाई -1 होता है. 1 माइनस कॉस पाई की पावर 4 माइनस कॉस 0 1 होता है, वो तो 0 ही हो गया. ओनली दिस पार्ट. कॉस पाई -1 होता है, माइनस माइनस प्लस हो गया. 2 हो गया 2 की पावर 4. 2 की पावर 4, 2 की पावर 4 से एक 2 कैंसिल हो गया. 2 की पावर 3 बच गया. 2 की पावर 3 का मतलब 8 बच गया. तो 8 डिवाइडेड बाई 3 पाई ए क्यूब. तो वॉल्यूम निकालना क्यूबिक यूनिट.
नहीं सर.
ठीक है. दिस विल बी द आंसर. ये आपका आंसर बन जाएगा. तो इस तरह से आप वॉल्यूम बाय द रिवॉल्यूशन निकाल सकते थे. वॉल्यूम बाय द रिवॉल्यूशन निकाल सकते थे. नेक्स्ट हम करते हैं, वी शुड स्टार्ट द गामा फंक्शन. नेक्स्ट हमने जो करना है, नेक्स्ट टॉपिक इज गामा फंक्शन. we have a function, particular function that is a gamma function, which is of the definite integral. A particular type of the definite integral. Standard name is a gamma function. How to define it? If n is a positive, then the definite integral, this integration 0 to infinity e raised to power minus x raised to power n minus 1 dx, which is a function of n after integration, is called the gamma function. Or another name for this is gamma function is Euclidean integral of second kind. The famous name for this definite integral is gamma function and is denoted by this gamma of n. Therefore, gamma of n is equal to integration 0 to infinity e raised to power minus x raised to power n minus 1 dx for n greater than equal to 0. This is the definition for the gamma function. It is a particular type of the definite integral having the limit 0 to infinity, and integrand is e raised to power minus x raised to power n minus 1 dx for n greater than 0. In particular, for consider n is equal to be 1. For n is equal to be 1, gamma of 1 will become integration 0 to infinity e raised to power minus x, because n is equal to 1 minus 1 x raised to power 0 is 1, that is dx is equal to integration for this part e raised to power minus x divided by minus 1 0 to infinity. For the upper limit, it will become e raised to power minus infinity, that will become 0, and for the lower limit e raised to power 0 is 1, and minus cancel with the lower because of the fundamental theorem of the integral calculus, that is minus times of the lower limit, that is 1 only. So it means gamma function of 1 is equal to be 1. Now we try to develop a reduction formula for the gamma of n. Reduction formula, which will be very useful to find out the gamma function for the negative value as well as the positive value for gamma of n. That is gamma of n plus 1. We define here gamma of n, in which what we have x raised to power n minus 1. If we consider here as n plus 1, then it will become x raised to the power n. So that's why, the same way we consider gamma of n plus 1 is equal to be integration 0 to infinity, only the change in the power of x raised to power n dx, only the change the power of x. Now just to integrate it with respect to x by parts, so as per the rule of Eilert, this is a u function, this is a v function. Integrate by parts. Integrate right hand side by parts. We get gamma of n plus 1 u function as it is, integration of v zero to infinity minus integration of derivative of u, that is x raised to power n minus 1 into integration of v dx whole integration. This will be the formula for the integration by parts. In first part, integration of e raised to power minus x is e raised to power minus x divided by minus 1, that will become minus times of x raised to power n into e raised to power minus x 0 to infinity, plus again the integration in the second part, integration of this part having the negative sign, that negative sign convert this negative sign as a positive sign. So that it will become a positive plus 1 plus n times 0 to infinity x raised to the power n minus 1, and integration of this will become e raised to power minus x divided by minus 1, that comes out dx. Then for the first part, because we have the limit x tends to infinity, this is the case of the limit x raised to the power n divided by e raised to power x, it will become 0. This is the formula for the limit. When limit x tends to 0, x tends to infinity, x raised to the power n divided by e raised to power x is equal to 0. So means for the upper limit, this will become 0, and for the lower limit as well as this will become 0 because of the multiplication in x. So first part will vanishes for the all the part as well upper limit as well as the lower limit. Only the remaining is the second part, that is n times of the integration 0 to infinity e raised to power minus x raised to the power n minus 1 dx, which is as per the definition of the gamma function will become gamma of n. It means our reduction formula will become gamma of n plus 1 is equal to be n times of the gamma of n times of the gamma of n, which is the reduction formula, which is the reduction formula for gamma of n. In this case, we have considered as per the definition n is positive, so we consider some remark. If n is positive integer, or you can say the natural number, n is a natural number, or you can say the positive integer, then by repeated application of this reduction formula, we have gamma of n plus 1 is equal to be n times of gamma of n. Now this consider gamma of n, again consider as a, that is n times of gamma of this, consider as a n minus 1 plus 1, like this one. We write this n as a n minus 1 plus 1. It means this consider as a n. To apply this one, that is n into, again apply the reduction formula, n times of gamma of n minus 1. Then next again apply the similar way, n into n minus 1, n minus 2, gamma of n minus 2, and continuing like this way. It will become n into n minus 1, n minus 2, and so on, that is 3, 2, 1. In last one we have the gamma of 1, because it is a natural number reducing up to 1. So it will become factorial n. It will become factorial n. And since we have already defined gamma of 1 is equal to be 1, and it means gamma of n plus 1 is equal to be factorial n for n belongs to the positive integer or the natural number. Gamma of n plus 1 is equal to be natural number, factorial n. Now second remark to consider as a remark 1, when n is a positive integer. Remark 2, if n is a positive fraction, if n is a positive fraction, then the repeated application of the, then by repeated application of reduction formula, we have gamma of n is equal to be n minus 1, n minus 2, and so on, go on decreasing by 1, This series of factors being continued so long as the factor remains positive, as the factors remain positive, multiplied by gamma of last factor. Gamma of last factor. You can see in the above also. In last one we have the 1, then multiply with gamma of 1. In last one we have the n minus 2, multiply with gamma of n minus 2. Last one we have n minus 1, gamma of n minus 1. In the same way, goes on decreasing by 1, and in last one up to that remains, the factor remains positive. We goes on decreasing by 1 up to that the factor remains positive, and in the at the last multiply with the gamma of last factor. Gamma of last factor. Thus we have therefore for example therefore we consider an example. For example, gamma of you can consider the gamma of 11 by 2. That is 11 by 2 can be written as gamma of 9 by 2 plus 1. That means 9 by 2 into gamma of 9 by 2. Similarly, you can consider 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2, and in last one gamma of 1 by 2, like this. So 9 by 2, that means gamma of 11 by 2 is equal to be this part. That is 9 by 2, start from 9 by 2 by using the reduction formula repeatedly up to that factor. The factors remains positive. Up to that, the factors remain positive, and at the last, multiply by gamma of last factor. That is, in the last, we have the 1 by 2 to multiply with gamma of 1 by 2. The value of the gamma of 1 by 2 can be obtained using the table of the gamma function, or it may be evaluated some standard formula also. The value of gamma of 1 by 2 can be obtained from the table of gamma function, or gamma of 1 by 2 can be evaluated using some standard formula, which will be discussed further, जो हम आगे डिस्कस करेंगे. ठीक है, 1 by 2 के लिए, only for the gamma of 1 by 2, not for the other. जैसे if we have the gamma of 3 by 2, उसके लिए formula standard नहीं है. That is using from the gamma table, gamma function table. Third remark, we have the gamma of n by n plus 1 is equal to be n times of gamma of n. We can also consider like this one, gamma of n is equal to be gamma of n plus 1 divided by n, provided n not equal to 0, n not equal to g. Then it can be written as multiply n by n plus 1 and divide also n plus 1. So what we get? We get n into n plus 1 in the denominator. So it can be written as gamma of n plus 2 using the reduction formula, n into n plus 1, and here you will get the provided n not equal to 0 and not equal to minus 1. Like this, then again multiply with n plus 2, gamma of n plus 2 divided by n into n plus 1 into n plus 2. That can be written as gamma of n plus 3 divided by n into n plus 1 into n plus 2, provided n not equal to 0, minus 1 and minus 2. And continuing like this, in general what we get? We get gamma of n plus k plus 1 divided by n into n plus 1, n plus 2, n plus 3 up to n plus k. You can see here we consider n plus 3. In the denominator, last factor is n plus 2. We consider gamma of n plus 2. In last factor in the denominator is n plus 1, and 1 less than the of the gamma function. In the same way, we consider here as n plus k plus 1. The last factor is n plus k. Provided n not equal to 0, minus 1, minus 2, minus 3, minus 4 up to minus k. These are not to be considered. N is equal to, n not equal to 0, not equal to minus 1, not equal to minus 2, and so on. So thus results defined for n less than 1. Thus this result defines what is in left hand side. In left hand side we have the gamma of n. In left hand side we have the gamma of n. Defines gamma of n for n less than 0. K being the least positive integer. Such that n plus k plus 1 should be greater than 0. Should be greater than 0. For example, what we would like to evaluate? We would like to evaluate gamma of minus 3.4. Minus 3.4. And what we have? N plus k plus 1 is greater than 0. This implies minus 3.4 plus k plus 1 greater than 0. This implies that is minus 3.4 plus 1 minus 2. That means k greater than 2.4. We choose k is equal to 3. That is greater than 2.4 is 3, because a positive integer, because we have considered here as a k being a least positive integer. K being a least positive integer such that this condition is satisfied. So when this condition is satisfied, then k being the least positive integer means k is equal to 3. Consider k is equal to 3. Therefore, gamma of minus 3.4 will become gamma of minus 3.4 plus k, that is 3, plus 1 divided by n, that is minus 3.4, n plus 1, that is minus 2.4, n plus 2, that is minus 1.4, n plus 3. N plus 3 means that is minus 0.4. K is 3. That then it is equal to be 3.4, that is minus 3 minus 0.4 and 1, that is 0.6. 0.6, gamma of 0.6. In denominator, we have become positive 3.4 into 2.4 into 1.4 into 0.4. So gamma of 0.6 can be evaluated from the table of gamma function. The value of gamma of 0.6 can be evaluated, obtained. From the Table of gamma function. Table of gamma function. One more thing is to be observed. Also, we observe that gamma of n is infinite when n is equal to 0 or a negative integer. For n is equal to 0 or a negative integer, gamma of n negative integer. Here we have considered as a fractional. That is in negative fractional. If it is negative integer or n is equal to 0, then this will be the infinity. Now evaluate the standard value of gamma of 1 by 2. Evaluate the standard value of gamma of 1 by 2. Evaluate gamma of 1 by 2. As per the definition of the gamma of n, gamma of 1 by 2, by definition of gamma function, gamma of 1 by 2 is integration 0 to infinity e raised to power minus x raised to the power n minus 1, that is 1 by 2 minus 1, that is minus 1 by 2 dx. This is to be changed into the polar coordinate. So we consider here a different variable because as we know that x is equal to be r cos theta and y is equal to r sin theta is the standard polar coordinate. That's why we consider here as a not a x, we consider as a different variable. That would be t e raised to power minus t raised to power minus 1 by 2 dt. Let t is equal to be x square, so that dt is equal to be 2x dx. 2x dx. This implies gamma of 1 by 2 is equal to integration 0 to infinity will become e raised to power t replaced with x square, that is e raised to power minus x square, and dt is t raised to power minus 1 by 2. Minus 1 by 2 is 1 by x, and that is dt is 2x dx. X will be cancelled with it, then it will become twice of 0 to infinity e raised to the power minus x square dx. That is gamma of 1 by 2 is equal to be twice of 0 to infinity e raised to power minus x square dx. Let it be 1. Because in definite integral, variable doesn't matter. We can also write gamma of 1 by 2 can be write as 0 to infinity e raised to power minus y square dy. Because in definite integral, variable doesn't matter. So we can also write gamma of 1 by 2 is equal to be twice of integration 0 to infinity e raised to power minus y square dy. Now we can use the result of the double integration. We use the result of double integration. What result we have? If we have f of x and g of y two functions are the functions of x and y only, and limit of integration and the limits of integration are constant. Limits of integration are constant. Then the double integral can be represented as a product of two integrals. As a product of two integrals. This will be the general rule for the double integral. That means if fx and gy are two functions of x and y independently, then and the limit of integration are constant, then the double integral can be represented as the product of two integrals using this rule. So multiplying that is above two equation 1 and 2. So what we have? So we have therefore integration c to d, that is integration c to d, integration a to b, f of x, g of y, g of y, dx dy is equal to be integration a to b f of x dx into integration c to d g of y dy. This will be the product of two integration. Now from equation 1 and 2, now from equation 1 and 2, or you can say multiplying 1 and 2, or you can say multiplying 1 and 2, multiplying 1 and 2, we get in left hand side we have the gamma function of 1 by 2 whole square. In right hand side what we have 2 to the 4 and the product of two integral, integration 0 to infinity e raised to power minus x square dx into integration 0 to infinity e raised to power minus y square dy. Then it will convert it to be double integral as per the above rule. Integration 0 to infinity e raised to power minus x square plus y square dx dy, double integral, it will convert it to be double integral dx dy. Now to evaluate this integral, change it to the polar coordinate. To evaluate this integral, change into polar coordinate. Polar coordinate with x is equal to be r cos theta, y is equal to be r sin theta, and dx dy will become r dr d theta. Therefore the region of integration in this integral, the above integral, in this integral is the complete positive quadrant. positive quadrant, because you can see, if you can see the positive quadrant, what means the x is 0 to infinity, y is 0 to infinity, so it means complete positive quadrant. Complete positive quadrant. To cover which r must vary from 0 to infinity and theta from 0 to pi by 2. 0 to pi by 2. This implies the gamma function of 1 by 2 whole square will become 4 times of integration 0 to pi by 2, integration 0 to infinity, e raised to power minus r square into r dr d theta. Then integrate it with respect to r first. It will become the, by considering r square as a p, 2r dr will become dp. So for integration with respect to r, put r square is equal to be p, 2r dr is equal to be dp. Then integration of e raised to power minus p dp will become e raised to power minus p divided by minus 1. This will be the integration. This implies gamma function of 1 by 2 whole square will become 4 integration 0 to pi by 2, and for this part will become minus 1 by 2 into e raised to power minus r square 0 to infinity. For the upper limit infinity, it will become 0. For the lower limit e raised to power 0, that will become 1, and this minus will become positive because one more negative sign with the lower limit. So it will become, this 2 will be cancelled with this 4, 2, that is twice of 0 to pi by 2, that is only 1 with respect to theta. That means 2 theta, integrate with respect to theta, integration from 0 to pi by 2, upper limit pi by 2 minus 0, that is only pi by 2, 2 cancel with 2, that is pi. It means gamma function of 1 by 2 whole square is pi, and gamma of 1 by 2 will become pi, square root of pi. This will be the standard value of gamma of 1 by 2, which can be used for anywhere in the successive questions or examples. यानी gamma of 1 by 2 is the square root pi. ठीक है, देखो आप ये देखो कि ये जो क्वेश्चन था, इस क्वेश्चन को कहाँ गया, ये दिस राइट हैंड साइड, ये जो राइट हैंड साइड है हमने पहले देखी थी ना, ये वाली इंटीग्रेशन में देखी थी ना, वहां पर वैल्यू पुट कर दी थी डायरेक्ट स्टैंडर्ड स्क्वायर रूट पाई बाय 2. या इस इंटीग्रेशन को आप, इट इज वेरी डिफिकल्ट टू सॉल्व, इस इंटीग्रेशन को सॉल्व करना बहुत मुश्किल है, बट यूजिंग दिस यू कैन सॉल्व इट. गामा फंक्शन का यूज करके हम इसको इजीली सॉल्व कर सकते हैं. तो गामा ऑफ 1 by 2 की वैल्यू आपके पास में स्क्वायर रूट पाई बनी. ठीक है, क्लास आपकी?
यस सर.
चलो ठीक है भाई, ठीक है फिर, ओके.
थैंक यू सर.